Hello, I'm Seth Daly. I'm a lecturer 3 at the University of New Mexico in the College of Pharmacy. I'm in the Department of Pharmaceutical Sciences. This is another video from our Calculation Success module. Today we'll be talking about the International System of Units, SI, or the metric system, and then how to use dimensional and ratio analysis to change units from the SI system and the imperial system back and forth. At the end, I'll also talk about some abbreviations and symbols you'll need to know for doing your calculations. We're going to start off talking about the metric system and using dimensional and ratio analysis. This information can be found in chapters 1 and 2 of Stoklosa and Ansell's pharmaceutical calculations. So if you want to go and check that out, it goes into more detail and there's lots of practice problems. So the International System of Units, also known as the metric system, it's better than our system. It just is. Everything moves in tens, hundreds, or thousands. Or if you're getting smaller, 0.1, 0.01, and 0.0001. Sorry, 001. It's really essential that you master these units, okay? And the reason is it's the foundation for all the math we do. So exam 1 is just about conversions in the International System of Units. But then in exam 2, you're going to take that new math you're learning and you're still going to convert numbers. So you'll need to be able to do both the conversion and the new math. So it's really essential that you get rock solid in the metric system. So this is just a chart of all of the acceptable conversions. Okay, so we have weight, length, and volume. And then these are some household measures that also do volume. Okay, so this is just a good reference point, and we'll talk about each of these in each section, but this is a good slide that has them all. All right, so we're going to start off with the gram. Okay, so this is a unit of weight, and the gram is the basic unit. Okay, so from the gram, we can go up to kilogram, and a kilogram is 1,000 grams. So kilo is 1,000, and if we go down, we go to milligrams, and 1 gram is 1,000 milligrams. If we're in milligrams, 1 milligrams is 1,000 micrograms. And if we're micrograms, that's 1,000 nanograms. Remember, micrograms can be written either as μg or mcg. They both mean the same things. This is more common in pharmacy practice, and this is more common in science practice. Remember, you can also do this with decimal places, where 1 gram is 0.001 kilograms. I prefer the thousands, but you may learn and know better how to use the 0.001. So how do we keep the order straight? Well, I came up with a mnemonic. King Godwin says, "My university nurtures pharmacists." And that helps me remember that gram goes up to kilogram, down to milligram, micro, nano, pico. So if I write this out at the start of my exam, then underneath I can write out kg, mg, mcg, ng, pg, and I know the order they're supposed to go in. And remember, every one of these is 1,000, okay? So each time you do this. All right, for volume, the liter is the basic unit. And so if we go from liter down to 1 milliliter, 1 liter is 1,000 mils, and 1 milliliter is the same as 1,000 microliters. Remember, MCL or microliter. And again, we can do it with that decimal math too. Now, the units are a little different here because we don't often use kiloliter or nanoliter. I don't really think I've ever seen kiloliter used, and nanoliter is very rare. So for this one, it's just liter, mil, and microliter. Those are the 3 big ones you'll use. If you look back, the M and the mic will still work. You're just changing the letter that comes after it. So now it's a liter instead of a gram, but it's still gram, mil, microgram. Okay, or liter, mil, microliter, okay? Now, one really essential thing we got to know is the deciliter, okay? And so these move in 1,000s, but the deciliter sits in between, okay? And I like to think of a deciliter as 1/10 of a liter. So if we write it out, it's a deciliter. So when I think about it, I think of 1 liter, and if it's a decimal, that's how we get to deciliter, okay? So it's 1/10 of a liter, okay? And so if we write that out, 1 liter is 10 deciliters, or 1 deciliter is 100 mils, okay? So this is a 10 step, and this is a 100 step, Okay, so this is weird compared to the grams where everything's moving in thousands. Here's one where we're moving in 10 to 100 between liters and mils. And so we have that extra units, okay? And you'll most often see this for like blood glucose. Okay, so blood glucose is normally like 90 mgs per deciliter. Okay, so that's how you'll kind of see those units in the medical literature, usually when you're looking at patient data. Okay, so we talked about volume. Okay, so here are the useful conversions. Okay, so 1 fluid ounce is 29.57 mils. We have a pint equaling 473 mils, a quart 946, a gallon 375. And then we know a gallon has 4 quarts, 8 pints, and is 128 fluid ounces. Now, I have these two in red, and the reason is if you only want to memorize 2 things, those are the 2 things to remember. And to make this one easier, there's a visual mnemonic we can use. A gallon has 4 quarts. And that nice little divider from the Q says we have 2 pints in each quart. Okay, and this equals 128 fluid ounces. Okay, so in this little drawing, I've rewritten all of this. 1 gallon, 4 quarts, 8 pints, and that equals 128 fluid ounces. So now if I know this drawing and this number, I can get to everything else. Okay, so really the things you need to memorize are these 2 and the teaspoon and the tablespoon, and you can get to all those other things. Now, you can memorize these if you want, but I find it easier to derive if I just know 2 things, so I'm not trying to memorize 1, 2, 3, 4, 5, plus how many of these things go in a gallon. That's a lot more to memorize. Okay, so that's how I do it. All right, next up is length. The basic unit of length is the meter, and I think length is the most confusing. And the reason is again, we have this meter into millimeter is 1,000, right? But then we have centimeter and millimeter, and this movement is 100, and this movement is 10. So from going to meter to centimeter is 100, centimeter to millimeter is 10, and if we go from meter straight to millimeter, it's 1,000, okay? And then micrometer, okay? So these are the ones that use the mnemonic, meter, milli, micro, and then this is the one that's kind of in between. We don't use kilometer in pharmacy, that would be over here. It's 1,000 more than a meter. We use that in practice when we're driving or something like that, but not often in pharmacy. All right, so we've talked about each component of the SI system. Weight is in grams, volume is in liters, and length is in meters, okay? And we've talked about the conversion factors for each, but how do we actually do a conversion? So that's what we're gonna get to next. So the first way we're going to do this is dimensional analysis. And the idea of dimensional analysis is we identify what our wanted units are, and then we take the given and multiply it by our conversion factors until that conversion factor equals our wanted unit. Okay? So what would that look like? So we have wanted equals given times conversion times a conversion. Okay, now, so let's say we wanted grams, but we're given milligrams. Okay, so for our conversion, we would know we want to cancel milligrams, so we put it on opposite sides. Okay, and milligrams goes up to grams. Grams is the bigger one, so I set it as 1, and we know that for every gram, we have 1,000 milligrams. Our units cancel, and so now our grams equals what we're looking for, and we can do the math. So 4 divided by 1,000 is 0.004 grams. Okay, so that's how you would use dimensional analysis. So here it is written out again, but this time we're looking for mgs per mil, and we're given grams per deciliter. Again, we're going to cancel grams by putting it on the bottom. It's the bigger one. We know there are 1,000 milligrams per gram. Okay, cool. Our grams cancel. Now we need to get rid of this deciliter, and we said that 1 deciliter equals 100 mils. Remember, the deciliter's on top, so it cancels. And now, if we look, our final unit is going to be in mgs per mil, And that's what we're looking for, so we can do the math. 100 times 1,000 divided by 100 is 1,000 mgs per mil. Okay, so that's how you set up dimensional, and that's how you would convert a unit. All right, well, what if we want to go from the imperial system into the metric system? So in that last example, we were just moving within the metric system. So in this example, we're looking for centimeters. We're given inches. We know that 1 inch is 2.54 centimeters. Our inches cancel. Cool, we're left with centimeters, which is what we're looking for. So we can do the math. 37 times 2.54 equals 93.98 centimeters. Okay? Now, everybody always asks me, why do we have to use 29.57 and why can't we use the 30 mils per fluid ounce? Well, let's think about it. In this example, your patient needs 96 fluid ounces of medicine. How many mils should you dispense? Again, remember from my other videos, I underline my knowns and I circle what I'm looking for. Okay, so 96 fluid ounces. I want mils. So we need to get rid of fluid ounces. We want to go to mils. So remember, 1 fluid ounce is 29.57. Ounces cancel. And we can do our math. That gives us 2838.72 mils. Now, if we were to do that same thing using the rounded number, okay, remember this is not what we use, equals 2880 mils. Okay. So the difference here is 41.28 mils, okay? So we could be off by 41 mils if we use the 30 mils. So what if your medication costs $5 per milliliter? So we're 48 mils off times $5. Sorry, 40, was it 41? 41, not 48. My apologies. Handy dandy eraser. 41 mils. We've dispensed $205 of extra medication, okay? So that's why it's essential that we use 29.57 and not 30 mils, because when we're going up to a big volume, it really does make a difference and it changes the math that or the result from the math, okay? That's why we have to use that specific conversion, okay? So let's do one more practice with dimensional analysis. Again, we're going from metric to metric. We're just changing what our units are. We want grams and we're going to micrograms. So microgram, and if we remember, K, King, Godwin, my university nurtures pharmacists. Okay, so micrograms go up to milligrams. Milligrams is the bigger one, so that's our 1. Cool, micrograms cancel. Migs don't equal grams, so we have one more to do. Migs go to gram. And gram is the bigger one, so that's our 1. This is our 1,000. Milligrams cancel, and now we're left with grams. So when we do that math, 1256 divided by 1,000 divided by 1,000 equals 0.001256 grams. Okay? So that's dimensional analysis, and you can use it from going within the metric system or from going metric to standard and then standard back to metric. Okay? So you can do all of those. Well, what about ratio analysis? Ratio analysis does the same thing as dimensional. We just set it up different, and we generally use it in different scenarios. So it's more useful for converting ratios. Now, the note here is the units are on the same on the top and bottom because they're on the other sides of the equals equation, okay? So if we're saying A is equal to B, A over B is equal to C over D. So there are two ratios, A over B equals C over D. So in our example, our vial contains 5 mgs per mil. How many milligrams are in 6 mils. Okay, so 5 milligrams over mils is our first ratio. Okay, A over B is equal to X milligrams, that's what we're looking for, in 6 mils. This is C over D. We're setting two ratios equal to each other. And if you notice, units are on the same side because they're on the opposite sides of the equal sign. Okay, so now we're going to cross multiply. 5 milligrams, 6 mils equals X milligrams, 1 mil. Remember, when we have it on the bottom here and there's no unit, we're just assuming that it's a mil. It's 5 milligrams per 1 milliliter, but we say it 5 milligrams per mil. Okay, we need to get X alone, so we're going to divide both sides by 1 mil. Our 1 mils cancel on this side, and on this side, just the units cancel, and we're left with MIGs equaling MIGs. Cool. So we can just do the math to find X. X equals 5 times 6 divided by 1, which equals 30 mils. Okay? Now, you could have done that in a simpler step using dimensional. So we could do this with dimensional. So we want milligrams. We're given 5 mgs per mil, and we're given 6 mils. Those cancel, okay? And so we just do 5 times 6 equals 30 milligrams, okay? So dimensional and ratio do the same thing, it's just how they make sense in your head. Here we're setting two ratios equal to each other, and here we're doing it dimensionally where we're just using our knowns to get to a final value. Okay, and so you can use both, and some people like ratio better and some people like dimensional better. Both will get you to the right answer, and for me, I use them in different places. So I use ratio when I'm really trying to compare two things that I'm making a proportion out of, and I use dimensional when I'm just usually doing unit conversion straight. Okay, so remember, this is dimensional. All right, so let's do another practice. So if a vial contains 5 mg per mil, how many mils would contain 27.5? All right, 5 mgs per 1 mil equals, okay, we need the mgs on the top, 27.5 milligrams and X mils. Okay, our units match, so we're good to start the math. We're going to cross multiply. 5 mgs X mils equals 1 mil times 27.5 milligrams. We need to get the X alone, so we're going to divide both sides by 5 milligrams. The 5 milligrams cancel. On this side, just the units cancel, and we're left with mils. So now we can just solve for X. 1 times 27.5 divided by 5 equals 5.5 mils. Okay? And that kind of makes sense. 27.5 is almost 25 milligrams. And if we divide 25 by 5, we should be right around 5 mils. Sure enough, that's our answer. Okay? So that's ratio. So how do we attack a problem? So this is what your problems are going to look like on your exams. We're going to have a question stem. Okay, so like this would be question 1, and then we're going to have a box to put in our answer. Okay, so when I'm attacking this, what I would do, how many tablets, okay, that's what I'm looking for, each with 75 milligrams, can you make from 2.3 kilograms of API? Okay, so I've underlined the values, I've circled my objective, and I know what unit I'm looking for. I'm looking for tablets. So I'm going to go ahead and put that in the box. So when I come to write my number in, if I'm not in tablets, I know I've done something wrong. So next, let's set up our equation. Okay, so we know that the tablets each contain 75 milligrams. So 75 milligrams per tablet. Okay, and we have 2.3 kilograms. We're going to put it down here because we know it's a mass, and we're going to try and cancel it with the milligrams. Okay, so I'm using dimensional here. So let's get those kilograms into milligrams. So remember, K, G, mg, mcg, nanograms, picograms. King Godwin says, my university nurtures pharmacists. Okay, so kilogram goes down to gram. This one's bigger and it's 1,000. Okay. We're going to go from gram. Next down is milligrams. This is bigger. So divided by 1,000. Cool. And our milligrams are going to cancel. But our tabs are on the bottom. Shoot, we wanted tabs on top. So all I'm going to do is reverse this fraction. Okay. And then I'm going to rewrite everything. Kilograms, 2.3. 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. Okay, let's make sure things cancel. Now we have tabs on top, so we can just solve. So 2.3 divided by 7 times 1,000 times 1,000 equals, we can make 328,571.4286 tabs. Okay? And remember, we can't make a fraction of a tab, so our final answer is going to be 328,571 tabs. All right, so that's how I would set up an answer. All right, so for your unit conversions, practice, 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 okay? SI and unit conversion are the most important thing to learn in calculations, and the reason is you're going to do it for a step in every single other problem you do. And you have to do the unit conversion correctly if you want to do the rest of that problem correctly, so you got to be able to do these. Now, the more you practice, the better you get, so if you do them fast, it helps. The reason is it gives you more time to think on the exam. If you can do your unit conversions quickly, then you're just worried about thinking about how to do the rest of the math in the exam. So practice, 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 okay? All right, the last thing I want to talk about in this video is abbreviations and symbols, because you'll start seeing these in calculations problems, okay? So this table is found in chapter 4, page 62, and there's a lot of abbreviations, and I just pulled out the few that I think are the most important for you to learn that you'll see the most often, okay? So you need to memorize these because they won't be explained on the exams, okay? So AA means of each. So it could say something like 2 magnesium sulfate and iron sulfate, AA, of each. So 2 of each. Add or QS, these both mean the same thing. They both mean add to or quantity sufficient. So you might see something that says a recipe and then says QS 100 mils. That means you fill in the rest of the recipe and then you add the volume up to 100 mils. These are standard for doses, BID, TID, and QID. Bis in D, tris in D, quat in D. These mean 2, 3, or 4 times a day. Okay? So this is for like a dose of a pill or milliliters or something like that. The last one is GTT, and that's an abbreviation for a drop. Okay, so like an equilibrated eyedropper, for example, it might say 5 GTTs, and that means you use 5 drops. All right, the next one are standard solutions we use. So these are what you'll see in the hospital. So starting over here, half normal saline is 0.45%, which makes normal saline 0.9%, right? So it's half of that. D10W means dextrose 10% in water, okay? So obviously this means dex 5% in H2O. All right, this one, dextrose 5% in normal saline, or 0.9% saline, okay? And then this last one is dextrose 5% in lactated ringer, okay? So these are all just different solutions that may be in part of your problems, and knowing what they stand for will help you, because you may need the percentage of dextrose, you may need the percentage of normal saline while you're doing that math. Okay, so make sure you memorize these. All right, so that concludes what we were working on. So we talked about the metric system, okay, so the SI system, dimensional, and ratio proportion analysis, and how we use those to convert grams, liters, and meters. So remember, this is weight, volume, and length. So go out there and practice, practice, practice. Make sure you can move within the metric system, and then you can move within the metric system into the imperial system, okay? So for example, you could go grams into pounds, or you could go liters into pints, okay? Or you could go meters into inches. And remember, you need to be able to go back from all of these too. So practice, practice, practice until all of these are second nature. All right, and if you have any questions, you can send me an email at sdaly@salud.unm.edu. Good luck in your calculations.